Name the nuclear reaction represented by the equation. The equation represents a nuclear fission. Calculate the total mass before the nuclear fission. The total mass before the nuclear fission equals to the mass of neutron plus the mass of uranium-235. Thus, the total mass before the nuclear fission equals to 236.05259 atomic mass unit. Calculate the total mass after the nuclear fission. The total mass after the nuclear fission equals to the mass of krypton 90 plus the mass of barium 144 plus the mass of 2 neutrons. Thus, the total mass after the nuclear fission equals to 235.85981 atomic mass unit. What can you say about the total mass before and after the nuclear fission? Comparing both total masses, it can be seen that the total mass before the nuclear fission is more than the total mass after the nuclear fission. What is the change in mass in atomic mass unit? The change in mass equals to the total mass before the nuclear fission minus the total mass after the nuclear fission. Thus, the change in mass is 0.19278 atomic mass unit. What is the change in mass in kilograms? Since 1 atomic mass unit is equal to 1.66 times 10 to the power of negative 27 kilograms, thus the change in mass is calculated to be 3.20015 times 10 to the power of negative 28 kilograms. Since the total mass before is greater than the total mass after the nuclear reaction, then the change in mass is actually a loss in mass, or known as a mass defect. Thus, the mass defect is 3.20015 times 10 to the power of negative 28 kilograms. What happens to the mass defect? According to Einstein's theory of relativity, the lost mass is converted into energy. Einstein's mass-energy equation, E equals mc squared, where E is energy, m is loss in mass or mass defect, and c is speed of light. Thus, the energy released during the fission of one uranium-235 atom is 2.8801 4 times 10 to the power of negative 11 joules. Energy can also be expressed in electron volts, where 1 electron volt is equal to 1.60 times 10 to the power of negative 19 joules. Calculate the energy released in this nuclear reaction in mega electron volts. Thus, the energy released is 180 mega electron volts.